Wonderful. So if you go into the spec, it starts the specification. It tells you when. So every time you download some online, you need to check that you are downloading the 9 to 1 specification. That's the current one we were working with. And to confirm, it says for teaching from September 2016 onwards, for exams in 2018 onwards, then you know that you are in the right spec. Okay. Page 2 is your table of contents, which is good. And it tells you exactly where to find what. We will come to the general admin and a few things. But if you look carefully, it says point 7 is mathematical requirement, right?
Yeah.
Mathematical requirement is something which is actually tested even in the bio papers. We do have a math component. So you see questions where it asks you for a calculation of an average or a calculation of the range or to draw a graph. So you are required to have certain mathematical skills, and you need to know which skills are required for bio. The ones required for bio are totally different from the ones you need for physics and chemistry. Yeah? Because the nature of the courses are different. So you need to be absolutely clear what each one requires so that you know how to strategize and meet those needs. And if you look at point 8 says practical assessment. Do you see that?
Yeah.
And under point 8, there are 2 points. There's 8.1, which is the use of apparatus and techniques. So that's selecting the right equipment, writing a method, making sure that you know things like you don't measure volume with a beaker. If you're looking for accurate volumes, you might use a pipette or a burette instead of a measuring cylinder. Those things are 8.1, and 8.2 is the required practical activities. The specification actually does have a list of practicals that you need to have done before you come to the exam. And so they would give you either questions for you to describe those practicals or to use knowledge from those practicals to answer specific questions. Okay? So as I said to your mom, I would be looking at those skills to start with this summer. We would do working scientifically. And if you notice carefully on the specification, these things are actually put in 3 places. It is point 3, working scientifically. It is split into 2 parts, point 7 and point 8. So it is a huge part of the course, right? 40% of the course. You can actually pass the course almost without knowing any of the subject content if you've understood the simple thing. And you can also know all the subject-specific details. If you've not taken care of this admin, your grade will also not be what you expect. So that's why I always start the course from here, okay? So let's have a look. Let's go to page 9 on the spec, because page 9 is where working scientifically is. Point 3, working scientifically. Do you see it?
Yeah.
Good. And it says science is a set of ideas about the material world, blah, blah, blah. I'm not going to read that to you. But there's a table which says 1, development of scientific thinking. Do you see that?
Yes.
And it says WS 1.1, understand how scientific methods and theories develop over time. And you will find that a lot of kids would have seen some of these things in Key Stage 3, and teachers assume you still remember them. We might not go over them, but these things are still examined on your GCSE, and it gives you examples of what students could be asked to do in the exam. This is absolutely critical because I need you to know what is coming. AQA doesn't lie. AQA doesn't hold information. AQA tells you exactly what they would do. So you need to read these documents in order to understand what is coming so you can prepare for it, yeah? It says, give examples to show how scientific methods and theories have changed over time. And an example in physics might be the theories of the universe. So on the spec, you would see the geocentric model where people thought the Earth was the center of the universe. And that model seemed to work for a while until people got telescopes and we sent probes into space. And then we actually realize the Earth itself is going around the sun, and the sun is in a galaxy, and the galaxy is not even the biggest one. So, of course, the Earth is not the center of the universe. The center of our solar system is actually the sun and not the Earth. So we've moved from the geocentric model, and we've now moved on to the heliocentric model. That's an example of WS 1.1, and these are things you need to know. There are quite a few examples, yeah? The second one is to explain with an example why new data from experiments or observations led to changes in models. So there was Galileo's experiment with Jupiter. He looked at the moons of Jupiter, and he took drawings of what was happening to those moons over a period of time. And then he discovered those moons, looking at the positions that they took over a period of time, were not going around the Earth at all. They weren't actually going around Jupiter. Once you see evidence like that and it doesn't support your current understanding, the only common sense thing to do is to change the working model at that time, right? And so we did decide whether or not giving data supports a particular theory. So in those ones, they will give you something and ask you, looking at this table, does this support the heliocentric model, or does it support the geocentric model? And you've got to look at the data, identify the patterns in the data, compare that with the hypothesis, and see which one it supports. Yeah, that's WS 1.1. Going down a little bit, you will see WS 1.2. Use a variety of models such as the representational, spatial, descriptive, computational, and mathematical to solve problems, make predictions, and to develop scientific explanations and understandings of familiar and unfamiliar facts. Does anything in that table surprise you? Nothing surprises you?
No.
Okay. The one I was expecting to surprise you is WS 1.3. WS 1.3 is one kids find difficult traditionally because they expect that science does have the answers, right? But we don't know things for sure. We are just attempting to explain. And so it will ask you to evaluate. Those WS 1.3 questions are evaluate. Evaluate the set of data, and you are supposed to find good things about that data, not so good things about that data, and you need to give me your conclusion with your opinion. I still think it's rubbish data because even though it has positive things and negative things, all the positives are weak. Or I think, although it's got a few weaknesses, it is still credible because it has more positives than negatives, stuff like that. That's WS 1.3. So all those things, we go through point 2, the experimental skills and strategies. That is still part of working scientifically. And then you go to point 3, analysis and evaluation, which is on page 12. That is all still working scientifically. We continue all the way until you get to page 14, and you will find page 14 deals with the link I sent you earlier: scientific vocabulary, quantities, units, symbols, and nomenclature. Can you see that? Page 14 on the spec.
Yeah.
Good. So vocabulary was the first one. That was the document I sent you earlier today. You need to know those vocabulary. There is no negotiation with that one. So when we finish class today, take some flashcards. If you don't have some, ask mom to buy some for you. Get some flashcards. Go through the ones that you are not familiar with. You write the keyword on one side of the flashcard and you write the definition on the other side. And over time, you will simply flick through those flashcards until you are familiar with the definitions, okay?
Yeah.
Okay. The next item is quantities and units. You need to know the SI unit for time is seconds. You need to know the SI unit for energy is joules. You need to know power is measured in watts. You need to know the base units because they would give you the other units which do not work with the equations. And you've got to know how to convert it to the base unit in order to use. So, for example, every time they give you a question, they would give you the energy in kilojoules. And you will find some kids will take it straight from kilojoules into the equation and calculate. You will lose 1 mark. You should know that the SI unit is joules, not kilojoules. You should understand that 1 kilojoule is 1,000 joules. So if they give you 3.4 kilojoules, you are going to change it to 3,400 joules. And it is that 3,400 joules you will put inside the equation to calculate. So that's the quantities and units aspect. You need to know V is voltage. That's obvious. I is current. Not very obvious. R is resistance. It's a bit obvious. P is power. So you need to know the symbols. And you also need to know the nomenclature. The nomenclature is things like how many decimal places you need to write your answer to. If I ask you for 3 significant figures, do you even know what significant figures are? Do you know how to write your answers in standard form? Because sometimes we will specifically ask you to leave your answer in standard form. And these are the math skills you have to have in order to be able to do well in the sciences. So you see, getting a good grade is not just revising a lot. It's not just about the content. It is actually a strategy. There's a strategy into getting the grades that you are after. And I want to work through that strategy with you over this series, okay?